Hello everyone, welcome to Math Tired Club, where we make all those hard things in math very, very easy. I hope you're doing well. Don't forget to like, subscribe, and comment, and also share the videos with your friends. Also, don't forget to turn on notifications so that whenever I upload a new video, you will get notified immediately. I want to thank you for your comments and support. It really gives me a lot of enthusiasm to make better videos every day. Okay, today we want to talk about solving radical equations, different radicals with different indexes and like different styles, okay? So I'm gonna be back with my examples in 1 second. Okay, ta-da! I'm back with my examples and I'm gonna start from the first one and I'm gonna go on with the other examples. And I have started to I have actually tried to order them from the easiest to the hardest, okay? So the very first thing that you would do you have to remember this. The very first thing that you need to do in order to solve any radical equation is that you have to isolate the radical, okay? So for example, in this question, the first thing that I will do is that I'm going to move 3 to the other side. So it's like I'm subtracting 3 from both sides and I'm going to have 5 in the other side. After that, the next part that we need to do is to get rid of the radical. Since the index of the radical is 2 here and it's a square root, so if I raise both parts to the power of 2, then I can get rid of the radical. So it's going to be 2x minus 3 is equal to 25. Therefore 2x is going to be 28 and x is going to be 14. Guys, remember this, that whenever we find a solution for radicals, we need to check our solutions. Why is that we need to check our solution? One of the reasons is because of the domain, okay? Because a radical with an even index has a domain and we have to check our solution. So over here, what I'm going to do is that I'm going to check my solution. So the checking part is going to be rewriting what I have found for x in the original question. So it's going to be, the checking is going to be 3 plus radical 2 times 14 minus 3. We want to know if it's equal to 8 or not, okay? So 2 times 14 is 28, and 28 minus 3 is 25, and radical 25 is going to be 5, and 3 plus 5 is 8. So 8 is equal to 8, so this is going to be an accepted answer, okay? So I'm going to go with this one now. So over here, what I need to do again is to isolate the radical. Do I care about what the index is? No, it doesn't make any type of changes. So it's only the power that I would raise both parts to. So I'm going to move 1 to the other side, or I will subtract 1 from both sides. So it's going to be x plus 1 to the power of 3 is equal to 24. And then I would divide both parts by 3 because 3 is getting multiplied by it. So I'm going to have x plus 1 to the power of 3 is equal to 8. And the index is 5. In order to get rid of this 5, I would raise both parts to the power of 5. So this is what's going to happen. And I'm going to have, this is going to pay and come out of the radical. So it's going to be x plus 1 to the power of 3 is equal to, instead of 8, I can write 2 to the power of 3 and then to the power of 5. These powers are going to get multiplied and I'm going to have 2 to the power of 15. Now it's time to get rid of this power of 3 over here, okay? How am I going to do that? How am I going to get rid of the power of 3? Take a square root from both sides with the index of 3. Am I right? So, or in another way, I can say raise both parts to the power of 1 over 3. It's going to be the same. I'm going to write that so that we would both be working with exponential powers and radicals, because we know that a radical is an exponential power and it's just like in fraction form. So this and this will just get simplified, and x to the power of 1 is equal to 15, and 3 are also going to get simplified. It's going to be 2 to the power of 5. 2 to the power of 5 is going to be 32, and then x is going to be 31. And after this, I would check my solution, and I would see that it's gonna work in my original question, okay? So this was another thing. The next thing that I would like to solve for you is this one over here in the bottom. So I have x plus 7 minus 5 is equal to x. Again, what I need to do is to actually isolate the radical. So I'm going to move 5 to the other side. And then the index is 2. And in order to get rid of that, I would square both sides. So I'm going to have x plus 7 is equal to x plus 5 to the power of 2. Guys, pay attention to this part. This is the part that most of the students forget about and they would make a mistake. X plus 5 to the power of 2 is not just x squared plus 25. This is a special case. It's the first special case, okay? And it's going to be a2 plus 2ab plus b2, okay? So if I want to expand this, and I also have like a video on binomial expansion. I recommend you to watch that too. That is very helpful. I also have a video on special cases, factoring special cases. That is also kind of related to this, so you can watch that too. So it's going to be x2 plus 10x plus 25. That's going to be it. And then I would move, now that I have a quadratic equation, I will move everything to one side and just do GCF, special case FOIL, or quadratic formula. If I move this to the other side, I would do the addition and subtraction in my head. It's going to be plus 9x and then plus 18, because 25 minus 7 is going to be 18. This is not a special case, and this is not like a GCF situation, so I think it's gonna be simple FOIL, mental FOIL. I can do that mentally, guys. I also have like a video on mental FOIL and the regular FOIL too. I recommend you to watch that if you have any problems there. So it's going to be, this is the sum and this is the product. What are the two numbers that if I multiply them, I'll get 18? This is the product and this is the sum. And if I add them, I'll get 9. They are 6 and 3. So therefore, once x plus 6 is 0 and once x plus 3 is 0 and x is negative 6 and or x is negative 3. And when you check these both, they will both work, okay? So both of these actually work. Let me box them. Okay. So the next part is going to be the other one on the top over here. So guys, there is a difference between this one and the other ones that I've done for you until this very moment. The difference is because we have two separated radicals, okay? I have two separated radicals over here, so that makes this one a little bit different from the other ones. So what I need to do is that I cannot isolate any of these radicals here because they cannot get added or subtracted, because I can add and subtract radicals only and only if they're like radicals. I can't do anything like that, and I cannot isolate the radical. So what I'm going to do is that I'm going to square both sides. Okay, this is going to be a special case over here. Let me write this part separately. This is going to be a special case over here. It's a minus b to the power of 2. See, a. This is going to be the a part, and this is going to be the b part, okay? So it's a minus b to the power of 2, which is going to be a squared minus 2ab plus b squared, okay? So the a squared part is going to be radical 2x plus 1 to the power of 2 minus 2 times radical 2x plus 1 times radical x. And then b to the power of 2 is going to be radical x to the power of 2 is equal to 1, because 1 to the power of 2 is just going to be 1. This over here, the power is going to go inside this and it's going to pay and come out of the radical. So it's going to be 2x plus 1 minus 2 times radical. I would take both of these under the same radical and I will multiply it. So it's going to be like 2x plus 1 times x. I will multiply it in the next step. And then that one, radical x to the power of 2, is just going to be x like the other one, and it's equal to 1, okay? Something that I can do right away is crossing these ones out from both parts. 2x and x are like terms, so I can add them and write it as 3x minus 2 radical. I will use the distributive property and I will multiply these by that. So it's going to be 2x squared plus x is equal to 0. Now it's time for me to isolate my radical because I only have one radical and I can isolate it now. So 3x is equal to 2 radical 2x squared plus x. Now I can get rid of the radical by squaring both sides. So it is going to be 9x squared is equal to, guys, remember that this power of 2 is for this and this at the same time. So it's going to be 4 times, this is going to pay and just come out of the radical. So I will just write that. And then I'm going to distribute this back to this. So it's going to be 9x squared is equal to 8x squared plus 4x. I'm going to move everything to one side and I'm going to just simplify it in my head. I'm going to do it mentally. So it's going to be x squared plus 4x is equal to 0. And then GCF x times x minus 4 is equal to 0. Therefore, x is 1, 0 and x minus 4 is equal to 0, right? So, and then x is going to be 4 here. And I will box my answers. Don't forget that you need to check your solutions at the end, and when you check both of these solutions, they will both work in the equation, okay, and you will get the right answer. So guys, something that is very, very important, I just want to go over what I did. Rule number 1, you need to isolate the radical. Okay, and the rule number 2, you need to get rid of the radical. It doesn't matter what the index of the radical is. Whatever the index is, you would raise both parts to the power of the index to be able to get rid of the radical. If you have 2 radicals like this, you need 2 steps, okay? So first you raise both radicals since the index is 2 to the power of 2, but then you need another step to get rid of the last part, okay? So now pay attention to this one. This one, you know that radicals are just like fractional powers, right? For example, if you have, for example, radical 2, it means 2 to the power of 1 over 2. Or for example, if we have radical 5 with the index of 6, it means that we have 5 to the power of 1 over 6. Or if we have radical, I don't know, 3 to the power of 2 with the index of 5, it means 3 to the power of 2 over 5. We know that this is the meaning of a radical, okay? And if you don't know, I'm going to have a video on this too. I'm going to link it in the description box, and I'm going to link it here too so that you can watch it. But sometimes the radical are written in fractional power form. So is there going to be any difference there? No, there will be no difference, absolutely nothing. And wait a second. Okay. And the thing that you need to do is the same thing, okay? So in order to understand that, I'm also going to do this question, this one, using exponential powers for you to see that there is no difference, okay? So look at this question. This question has a point that I want you to pay attention to. This is a radical, okay? So the first thing is that I need to isolate the radical. So I'm going to divide both parts by 3. So it's going to be x plus 1 to the power of 2 over 3 is equal to 4. Is that correct? And then I have to raise both parts to the power of the reciprocal so that I can get rid of this power over here, or the radical in another way. So I would raise both parts to the power of 3 over 2. You might ask, teacher, what about the other part, 4 to the power of 3 over 2? We don't care about that one because that's just a number. We just want to make x to be able to come out of the radical, or out of that like fractional power, okay? So I'm going to do this, and this is going to get simplified. As you see, this is going to get simplified, this and this one, this one. So it's going to be able to pay and come out. But when I bring this out, I'm going to put this in an absolute value function, okay? And let me write this, and then I will explain why I did that. 4 is 2 to the power of 2, and to the power of 3 over 2, these will get simplified, and it's just going to be 2 to the power of 3, which is going to be 8. Now let me explain why I wrote an absolute value function, but for the other questions I didn't. The difference between this questions and the other ones is this 2 over here on the top. Okay, I want you to pay attention to something. When I say x to the power of 2 is 9, x can be both 3, that 3 to the power of 2 is going to be 9, and we know that. And it can also be negative 3, because negative 3 to the power of 2 is also positive 9, okay? Whenever I have a power of 2 on the numerator of my fractional power, I need to be taking care of this plus and minus situation. If I don't, it means that I'm just going to ignore one of the solutions that I can have, and it's going to work there. You know what I'm saying? So what's the thing that will give me that plus and minus solution? The plus and minus situation, it's the absolute value. So teacher, why didn't you do it in the other questions? Guys, in the other questions, I had no power of 2 in the numerator. For example, this one, it was 2x minus 3. It was 2x minus 3 to the power of 1 over 2. This power on the top was just 1. So there was no plus and minus situation there. So whenever there is a power of 2 or even power, by power of 2, I just don't mean the number 2. Sorry, excuse me. 1 second. Why did it went up? So by power of 2, what I mean is any even power, like 4, 6, 8, anything, because those even powers, when I have that, I have to know that there is going to be a plus situation and a minus situation, exactly like this example that I gave you, x to the power of 2 is 9. So that's why I will put this in an absolute value function. So therefore x plus 1 is going to be 8, and x plus 1 is going to be negative 8. Once x is going to be 7, and once x is going to be negative 9. I want to do the checking of both of these solutions, because you're going to see that both of them will work in this question. Look, checking. So first I'm going to check the 7 part. So it's going to be, we want to know if 3 times 7 plus 1 to the power of 2 over 3 is going to be equal to 12 or not. So 7 plus 1 is 8. And I know that 8 is 2 to the power of 3 to the power of 2 over 3. We want to know if it's 12 or not. This 3 and this 3 gone. And then 2 to the power of 2 is going to be 4. And then 4 times 3 is going to be 12. So yes, this is going to work, okay? And let me show you how the other one is also going to work. Look. Let me, okay, so look at this other one. So the other one is negative 9. So I'm going to check that too. So it's 3 times negative 9 plus 1 to the power of 2 over 3. We want to know if it's 12 or not. Negative 9 plus 1 is negative 8, and negative 8 is negative 2 to the power of 3 to the power of 2 over 3. So this 3 are gone. And 3 times negative 2 to the power of 2, we want to know if it's 12 or not. What is negative 2 to the power of 2? Positive 4 again. So did you just see what happened? So this is also going to work. So that's what even power does to my question. So guys, as I told you, I would like to do this other question with fractional powers so that you would see it's the same thing. Give me 1 second to rewrite it. So I rewrote the question again. Guys, see, if I were to do the same question with fractional powers, it was going to be the same thing. So 3 times radical x plus 1. So let me first change it to fractional power form. So if I want to change this to fractional power form, it's going to be 3 times x plus 1 to the power of 3 over 5, because I know that the index goes into the denominator, plus 1 is equal to 25. So I move 1 to the other side. It's going to be 24. Divide both parts by 3. It's going to be x plus 1 to the power of 3 over 5 is going to be 8, and 8 is 2 to the power of 3. So in order to get rid of this power, I would raise both parts to the power of the reciprocal, 5 over 3. So it's going to be, since here the power on the top is odd, there is not going to be a plus and minus situation, so I don't need an absolute value. So I'm going to have x plus 1, because these will cancel each other out, is equal to, and this one cancels this one, 32. And then I'm going to move 1 to the other side, and x is going to be 31. So see, very simply, you can solve the radical equations. So guys, I hope that you have enjoyed this lesson and you have understood. Don't forget to subscribe and like, turn on notifications. Thank you for watching this video. Have a great day. Bye.